A quick inspection shows this is a type 2 ionic compound. So we will want to start by naming the anion because we have a cation that can form multiple ions. Our anion is the oxide ion. Oxide carries a charge of 2-. Since there are two copper cations and only the single oxide, each of the copper ions must carry a 1+ charge. This combination would make for a neutral compound overall. So the name of the cation will be the copper 1 cation. The name of the salt, therefore, is copper 1 oxide. Be careful not to include a space between the name and the parentheses here. Also be sure to use capital Roman numerals. Canvas is case specific and lowercase numerals will not get you points. Again, we have a type 2 compound. So we will again want to start by naming the anion so that we can determine the charge on the cation. Our anion here is the sulfide ion. Sulfide is located just below oxygen, so just like oxygen, sulfur will carry a charge of 2-. Since there is a single copper cation in this case paired with a single sulfide ion, the magnitude of their charges must be identical. So the name of the cation would be the copper 2 cation. The name of the salt, therefore, is copper 2 sulfide. Another type 2 ionic compound. It's almost like these are the compounds students don't pay enough attention to while practicing and miss come quiz time. True story. Again, start by naming the anion. Our anion is the polyatomic ion sulfate. Sulfate is actually sulfuric acid minus its 2 hydrogen ions, so it carries a charge of 2-. Again, there's a single manganese cation paired with a single sulfate anion, and the magnitude of their charges must be identical. So the name of the cation will be the manganese 2 cation. The name of the salt, therefore, is manganese 2 sulfate. Know that even though we have a polyatomic ion, we did not need parentheses here. Students love to put every polyatomic ion in parentheses on their quizzes, which results in their getting the question wrong. We will only use parentheses if there are more than one of a polyatomic ion needed for our compound. Guess what? Another type 2 ionic compound! Name the ion, which is the polyatomic ion phosphate. Phosphate is actually phosphoric acid minus its 3 hydrogen ions, so it carries a charge of 3-. Again, there's a single cation paired with a single anion, so the magnitude of these charges must be the same. The name of the cation, therefore, is going to be the iron 3 cation. This makes the name of our salt iron 3 phosphate. Not another type 2 ionic compound. Finally! If you review this compound, it does not contain any metals. So lots of students choose to list this as a molecular compound and then try to apply molecular nomenclature rules to name it. No bueno, amigos. We do have covalent interactions present, but that's because we have covalent bonding within each polyatomic ion. Central nitrogen in the ammonium ion is covalently bonded to its 4 hydrogen atoms, and the central sulfur is covalently bonded to the 3 oxygen atoms in the sulfite. But those 2 ions are held together through the fact that ammonium has a 1+ charge and sulfite has a 2- charge, and there is an electrostatic attraction between them. Now, back to the question. The cation here is the ammonium cation. The anion here is the sulfate anion. Be careful, it looks a lot like sulfate, but it isn't sulfate, just related to it. So that's going to make the name of our compound ammonium sulfite. Another simpler one. The cation here is the calcium cation, and the anion is the phosphate anion. This makes the name of our salt calcium phosphate. No Roman numerals, easy peasy lemon squeezy. Ending this practice with another type 2. I mean, seriously, practice these or you'll miss them. It happens every semester. Start with the anion here, which is the sulfate anion. Sulfate carries a 2- charge, and there are 3 sulfate ions total, so this gives a total of 6 negative charges. There are 2 cobalt cations, which are going to share 6 positive charges so that the compound can be neutral. This means that each cobalt must have a 3+ charge, and that our cation must be named cobalt 3. Our salt is therefore named cobalt 3 sulfate.